when we started this whole workshop, one of the things we mentioned was that before you start doing your analysis, you need to have your do file. And then the do file would contain the various codes or commands in Stata that you are going to run. And we advised that the easiest way for you to create a do file is to do that in Stata by opening the do file in Stata and then preparing it yourself. When you are done preparing your do file, you need to keep it in a folder. So I remember Abdulaziz mentioned that you need to create a folder for each project that you are going to work on. And for this particular workshop, I have created a folder, and this folder contains a lot of files. But the most important files that I am going to use today is the training do file _2, which is my do file, and then the data set I am going to use, which is this particular one. So if you create your folder, you should have these two files in here. I have more than two because other data sets are in there and other do files, which I am not going to use, are in here. So don't be confused. When you create your folder, you should have two files, which is your data set and then your do file. And then your data set, once you download your data, you would have the original data set somewhere. It is advisable that if you are doing any project and you want to work in a folder, you copy the data set from its original source and then bring it to the folder. So when you copy it, it means that the original data set will still be in the original folder, but then the new data set that you want to use will be in the new folder that you have created. So that is what I would say before we start. So once you have your folder with your two files, the first thing you need to do is to open your do file. So I will just open this do file by double clicking on it like this. So my do file will open. So this is the do file we are going to work with. Some of the commands have been explained to you earlier, but I will just go over just shortly so that for those who are joining for the first time may have some understanding of what we are doing. So in Stata, before you start doing any analysis, you need to clear everything from the Stata data sets or the program, so that if you already have existing data sets in there or existing files in there, everything will be cleared. And in Stata, the command you use for doing that is the clear all. So the clear all command will clear the entire data set, but it will not affect the program. Then when you finish, the next one is to set more off. And the set more off helps to tell Stata to run the commands continuously without any interruption. So sometimes you run a long command, and when the results appear in the data set, you will see that there can be breaks somewhere. So if you set more off, you can run a command continuously and nothing is going to happen to that. And that is where you need to set more off before you start your analysis. The next thing you have to do is to set maximum variables to 32,000, depending on whatever data set that you are using. Some Stata versions will take up to 5,000 variables, others will take up to 2,047 variables. But the moment you set the maximum variables to 32,000, that is the highest you can go. So when you set it there permanently, it means that for any analysis that you are going to do, that is the number of variables that will be acceptable. So you need to do that before you start your analysis. The next thing you have to do is to change your directory. Directory is where you have your files, and that is the folder that I have created on my laptop. So when you go to my laptop and then you go to volumes and then this folder REMS consult, and then workshops, these lines all together is the directory that I have. And that is where all the files that I am going to use are located. The do file and then the data set that I am going to use, they are located here. So you have to have a change directory line so that you will be able to locate the various data sets that you are going to use. I'm sure Abdulaziz explained this to you, but if you want to get the directory, what you need to do is that you go to your folder. So I'm going to switch back to where I created my folder. So this is my folder. This is the folder I created. There are a lot of folders in here. Just forget about them. Look at this folder. The folder name is workshops. And within this folder is my data set and my do file. So if I want to change directory and then I want everything that I'm going to do to be directed to this folder, I just come down here. This might be different from those who are using Windows. I am using Mac, so this is how it works on Mac. So I come here, I right click on it, and then I copy workshops as path name. So I just copy it as path name. I come back to my do file, and then assuming there was nothing here, all that I need is two inverted commas here. So I clear what I have. I have already copied, so I just paste it by using the shortcut Control V, and then it comes here as the directory I am going to use. So this is where the data set is located. This is where my do file is also located. After you have changed your directory, you now have to capture log close. And capture log close means that any log file that you have anywhere on your laptop or in that particular folder will close, because you are now going to open a new log file. And I am sure log files have been explained to you. Any analysis that you are going to do will go into the log file. So before you begin or you open a new log file, you have to close any log file that is already existing. So you use the capture log close. After you have issued this command, you now go to open a new log file by using the log. So log using breast cancer underscore Ghana.log. This is the log file name that I am going to use. You can make it as short as you want. You can make it breast, you can make it cancer, whatever you want. It doesn't change anything. But the extension, which is the .log, has to come. If you don't bring it, it will not pick. And here we have append at the end here, comma, and then append. Abdulaziz explained to you that you can use append or you can use replace. What the append does is that it adds on to whatever results that you already have in the log file if you have already run some before. And then the replace means that it is going to replace what you already have. So if you already have a log file that is named breast cancer underscore Ghana.log, and then you use the replace instead of the append, whatever analysis you are going to do, the results are going to replace what you already have. If you use the append, it is going to continue. So that is the difference between the append and then the replace. Once we have done all these, we now have to go and locate our data set. And the data set is located in a particular folder. So that is the reason why you have to open a change directory. You have to run the change directory command, because if you don't run the change directory command and then you use this command to locate your data set, you may not find it. So once you have done this, it means that anything that you are going to do should be located in that particular folder. So when I go to the folder, this is the data set that I have here. So I have to go and copy the path name for the data set. And that one too is similar to how I copied the path name for the change directory. So I go back to the folder, which I have already opened here. And this is the data set that I am going to use. So when I click the data set, I come down here, I right click, and then copy this as path name. So I just copy, I go back to my do file, Assuming I don't already have it here, I just clean this one. I have two inverted commas, one at the beginning, one at the end. And then in the middle, I just paste the file name here. So once I paste it, it means that it will pick. And then it starts with use. So we are going to use this particular file name with this path name. So that is the file that we are going to use. When you are done with this, it means that your data set has opened. So the moment I run the command from the beginning up to this point, the data set will automatically open. Now there is no data set anywhere, so it has not opened. After you have opened your data set, the next thing you can do, and this one is not compulsory, you can decide to work in the data set as it is, or you can also decide to keep the variables of interest. To keep the variables of interest means that you have to know which variables you are going to work with per the project you are working on or the topic you are working on. And for this workshop, we are going to work on breast cancer screening. So women who were screened for breast cancer. Abdulaziz explained to you how you can identify each of the variables you are going to use. So I'm not going to spend a lot of time explaining that to you. But the key thing is that if you are looking at breast cancer screening, it means that breast cancer screening is your outcome variable. So in any analysis you are doing, we have your outcome variable and then we have your explanatory variable. Other people call the outcome variable the dependent variable, and then the explanatory variable, they call them the independent variables. You can only know your outcome variable when you know the topic you are working on. And then your explanatory variables, you have to read the literature to see which variables would explain your outcome. And that is where you identify all the variables you are going to use for your study. So if you are going to keep the variables of interest and not work in the entire data sets, what you have to do is that first you have to locate all the variables. And as you can see here, the variable name for breast cancer screening in the DHS, in the file IR file, that is the individual record file, is V484A. So I am going to keep this particular variable. Then the V000 is the country name. I am going to keep this particular variable because that is also important. Then we have V001. This is the cluster number. You should keep this particular variable because that is also very important in any analysis you are going to use using the DHS. We have the V005. This one is the variable that is used to generate the weight. And that one, we have spoken about it, that when you are doing any analysis with the DHS, you need to consider weight. And you have to generate a weight before you do your analysis. So this variable, you cannot do away with it. It has to be here. We also have variables like V021. This is the primary sampling unit. It is similar to the cluster number. You have to also keep this particular variable. Then we have the V022, which is the strata with sampling errors. You need to keep this particular one. And then the V023, which is also the stratification that was used for the analysis or to generate, to collect the data. So you need to also keep V023. So apart from V484A, which is the breast cancer screening variable, all the rest of the variables here from V00 up to V023 are mandatory variables that you are going to use in any project or any topic that you are going to work on using the DHS. So after you have kept these variables, now you have your outcome variable, you have the key variables that are needed for your analysis. Then you think about your explanatory variables. When we read around the literature, these were the explanatory variables we thought would explain breast cancer screening. So these variables have to also be identified in the DHS. We will pick all questions at the end of the training. So I can see somebody's hand up. I'll answer your question. Just keep it so that it doesn't disrupt the flow of the workshop. We will pick it at the end. Thank you so much. So there are variables that you need to identify before you can do your analysis. Those will be your explanatory variables. And you have to have them in mind before you start working on your analysis. So from the literature that we read, variables like the age of the woman, the educational level of the woman, the marital status, exposure to media, ethnicity, and other variables were identified as our explanatory variables. And these variables have been listed here. So as you can see, from V012 up to V024, these are variables that are going to be our explanatory variables. I wouldn't be able to tell you what each one of them means at the moment, but when you check from the data set, you will know which variable means what, and we are going to explain them when we go further. So all these variables are variables that are going to be used as our explanatory variables. So the decision is up to you. The moment you keep these variables in your data set, it means that there wouldn't be any other variable that is in the data set. All other variables will be gone. So assuming you do that and then you remember that, no, there is a particular variable I should have kept. I have to go and keep it. What it means is that you cannot do that when you identify it. You have to start running your do file from the beginning up to this point again to get the original data set before you can continue with this particular process once again. So probably it is advisable that you can work in the data set as it is without keeping the variables of interest, because all these variables I've mentioned will still be in the data set if we are working on the larger data set. Once you have done this step, so this step can be avoided or it can be taken into consideration depending on how well you are conversant with the variables of interest. When you finish with this, the next step you need to do is to generate your sample weight. And how do you generate it? You use the gen command in Stata. So gen is for generate, WT is our shortcut for weight. If you can write it as weight, you can write it anything. W, anything you want, it will pick. It's equal to V005. I mentioned earlier that V005 is the weighting variable that has been provided in the DHS data set. So V005 over or divided by 1 million. This line of command is what you use to generate your sample weight. And once you run this command, you will get your WT variable as your weight. The next step after you have generated your weight is to generate your survey set or the survey for the data set. This is important because when collecting the DHS data set, there are two processes or sampling strategies or sampling steps that are used in collecting the data set. The first one, you collect from the cluster. So we sample people from the cluster level, and then within the cluster, we collect data from individuals within a household. So it is a complex data set, not like any other data set that is collected using either a simple random sampling or purposive sampling or any other sampling technique. This one, you have a two-level sampling technique. So what it means is that you have to take into consideration the complex nature of the data set in every analysis that you do. So you have to generate a survey set variable that will be employed to take into consideration the complex nature of the data set. And the survey set will be useful when you are doing your inferential statistics like the chi-square test, like the logistic regression, ANOVA, whatever you want to do, you have to employ the survey set. But then when you are doing normal descriptives, like the means, the frequencies, percentages, you don't have to survey set the data when you are doing your analysis. You have to just add the weighting variable in your analysis, and then you are good to go. So these are also explanations for these two. Very, very important. You cannot do away with them when you are doing your analysis. Once you have generated the weights and then the survey set, the next thing for you to do is to now start with your actual analysis. What I have just said are just preliminaries, but they cannot be avoided. You have to do them before you start your actual analysis. So the actual analysis starts by looking at the outcome variable. Our outcome variable is breast self-examination. No, breast cancer screening. Sorry, breast cancer screening. So if you check, one of the things that we did to look for that particular variable is to open our data set and then look for cancer. This has been explained to you earlier by Abdulaziz, so I'm not going to spend so much time doing this. So we know that when we type this in Stata, we identified our variable V484A as the variable for breast cancer screening. In order for you to check if that is the variable, you have to use the frequency command. That is the free. So free V484A. And then you would see whether that is the variable that you are going to use. So what I am going to do is that now I am going to run the command from the beginning up to this point. Then all these other ones, we are going to do them step by step in our data set. So this is how we start. So clear all, set more off, set max var, our CD, capture log close, log using, and then we come to use, and then we keep all these variables and we generate our sample weight. So I will just highlight all of them from the beginning up to this point, and then I click on do, and then it will execute that. When it is executed, and then I come to my Stata, I will see that my data set has been opened here, as you can see. And then my do file 2 is here. So I have the two files open. Yes, so this is my data set. So as it stands, you can see that I have run all the commands from the beginning up to this point. All of them have run. When there is any error, it will be red, and then you will be notified here that there is an error. But here there is no error, so it means that we are good to go. We have been able to generate our sample weights. We have kept all the variables of interest, and then we have done our survey set, which is good. Now let's go ahead to look at our outcome variable. So what we are going to do basically is that we are going to run these commands to check our outcome variable. So free V484A. So when you highlight this command and then you click on execute, this is it. So breast examined for cancer by healthcare provider. And we will see how this has been coded in the DHS. So we have 0 as no, we have 1 as yes, and then we have 8 as don't know. You have all the frequencies and the percentages. What this is telling us is that there's no missing. Then when you use the free command in Stata, and then there's a missing, they are missing somewhere, or they are missing observation somewhere, it will show here. So here there are no missings. The total sample that we have is 15,014. So as you can see here, there are no missings. So what you have to do is that because there are no missings, and then this variable is in 3 categories. We have no, yes, and don't know. For the purpose of our analysis, we want to create a binary outcome. Binary means that you have to get yes or no, or any other 2 categories that you want. Categorize as 0 and 1 in order for you to get use them for your analysis. So before we do that, we have to recode the original variable using the recode command. So as you can see, that is what we have done here. So we have recoded V484A, which is our variable, and we made it 0 and 8. 0 is no, 8 is don't know. So these two categories together, we are calling them no. And then 1, which is the yes, we are calling 1 as yes, as you can see here. And then we are generating a new variable called breast test. And that is in a bracket here. So the moment I run this line of command by highlighting on it, and then I execute, it has created that for me. If I want to check whether what I want is what I have gotten, I just run this command, which is free breast test, which is the new outcome variable name. And then I click on execute, and then it will show me here. So as you can see, we have the no category as 12,537, and then the yes category, which is a combination of no and don't know, which is the yes, as 2,477. So you can see that I have my binary variable created for me. We have in mind, so before you even start your analysis, you should have in mind the kind of analysis you are going to do. And that will determine how you are going to code your variables. We have in mind that we are going to do regression analysis. And as part of it, we are going to do some chi-square tests. So if you are going to do chi-square tests and regression analysis, you need to have a binary outcome variable. And that is what we have done here to create this particular variable. And as you can see, the variables or the variable we have created should be numbers 0 and 1. The categories for the variables should be 0 and 1. If you don't make it 0 and 1 and then you run the regression analysis, it will not pick. So just bear that in mind, where we are referring to 0 as no and the 1 as yes. That is the first thing. Now you are finished creating your outcome variable. Let's go to the explanatory variables. With the explanatory variables, like I've mentioned before, you have to check literature to select them. And once you have selected them, you need to check whether there is the need to recode the variables or you have to maintain them as they are. So the first variable that we were interested in is the age of the woman. And in the DHS, there are two variables that measure age. One is V012 and the other one is V013. The V012 is the age of the woman as a continuous variable. So if you check, you can see it here. So free V012. So as you can see, these are the ages of the women from 15 up to 49. And here we are dealing with women of reproductive age. That is why the age categories are from 15 to 49. Then we have another variable, which is V013. This is the age of the women that have been grouped. So if you free V013, you can see the ages that we have here, which have been put into groups from 15 to 19 up to 45 to 49. So with this particular variable, we don't need to do anything to it because we already have the groupings here. And then when you check the frequencies and percentages, we don't have any of the categories having a very small number of observations to the extent that we need to add it to another variable. So in that case, we keep the variable as it is. In order to do that, you have to use the clone_var command in Stata. What the clone_var does is that it duplicates the variable by giving it a new name, but then still keeping the original variable. So when I run this particular command in Stata, and then I execute it, it has created a new variable called maternal age. But the V013, which is the original variable name for maternal age, is still in the data set. And I have my new variable, which is maternal age, also in the data set. That is very, very important. You need to do that in order to generate your new variable. When you finish doing that, you have to check whether the particular variable you have created is in the data set. So I'll run this particular line of command and then I execute it. And then it shows me here that the variable name maternal age is in here. Don't be confused. We are going to share this do file with you when we are done with the workshop. So anything you don't understand, just follow. And then you ask your questions at the end. If you are not comfortable with that also, when your questions are asked and answered, we will share the do file with you. You go through, and then if there are any issues, you can get in touch with us, and then we are going to explain that to you. Because you don't have the do file, sometimes it's difficult for you to understand what is going on, but just follow, and then you just understand the various steps that we are explaining. Thank you for that. So the next thing is that we are finished dealing with the first explanatory variable, which is the age of the woman. So the next thing we have to do is to look at the next variable, and from literature, we identify level of education of the woman as another explanatory variable, which is very good. And that one too, we were able to identify it from our data set, and the variable name is V106. So if you want to check whether that is actually the variable name, you have to free V016, 106, sorry. So when you highlight this line of command and then you execute it, you see that we have highest educational level with its categories as no education, primary, secondary, and higher. So these variables are also, this variable is also here with its categories as well. So what we are going to do is that for the sake of the analysis, we are going to give a name that we can remember. And we are going to call this particular variable education. So just as we did for the maternal age, we are going to use the clone val command in stata to duplicate this particular variable and have its equivalent name called education. So when I highlight this line of command and I execute it, I get a variable name education, and I'm going to check whether that is in there. If I want to check, I just type free education. I highlight that, execute it, and then it is here. The same variable which has been renamed. Okay. So sometimes you have to recode this particular variable depending on what you are working on. And it is up to you. Sometimes you will see that we have no education, primary, secondary, and higher. And from this particular categories, you can see that for higher, the number of observations are a bit smaller than the others. So sometimes when we are doing our analysis and we know that this number of observations are smaller, we can recode this particular variable and add the higher to the secondary so that it will become one category as secondary stroke higher. That is not important here because the number of observations here are a bit okay. So we can maintain them. The next variable, which is the explanatory variable that we are interested in, is marital status. And in the DHS, the variable name for marital status is V501. So we have to check whether actually that is the variable name. So we highlight free V501, execute it, and then we will check. Yes, that is current marital status. And we have its categories as never in union up to no longer living together or separated, with its frequencies and percentages. You can also see that for this particular variable, there are no missing values. All of them are total 15,014. The next variable that we are going to look at is, so once we have checked the marital status variable, for marital status, we have to do a recoding because as you can see, some of the categories of the variables have smaller number of observations. The reason for doing the recoding is that when you do your chi-square test or you do your regression analysis or any other analysis that you do, sometimes your odds ratios and your confidence intervals can be very big or very small. depending on the number of observations, if they are too small or too big. So in order to avoid that, you need to do a recoding. And here we have decided to recode the variable marital status into how many categories? 3. With the first category being never in union. This one you cannot do anything about it, so you maintain it as it is. So when we use the recode command, we have recode V501, a bracket opens, 0 is equal to 0, and we call that never in union. 1 is equal to 1, we call that married. Then 2 is equal to 2, we call that cohabitation or living with a partner. That is the original variable label. Then 3 to 5, 3, 4, and 5, we call that previously married. And then we generate a new variable name called marry. So that is the new variable name that we have for marital status. Once you run this line of commands from here up to this point, we are going to get a new variable name called marry with different categories from the original. Then we run free marry, and then we will see that now we have our new variable called marry with 4 categories: never in union, married, cohabitation, and previously married. This is better than the original variable that we had. After we have finished with that, the next explanatory variable we are interested in is religion. So for religion also, the variable name in the DHS is V130. And for religion, when you free V130, as you can see here, we have a lot of categories of that particular variable. We have Catholic, Anglican, up to other. It will be confusing for the analysis. So what we do often is to recode this particular variable, and we are using the Ghana DHS, the 2022 Ghana DHS. So these are religions or religious groups that are in Ghana. So as a Ghanaian, I know which of these categories I'll call Christian, which of them I'll call Muslim, and which of them I'll call traditionalist. So we have to recode this particular variable. So I know that Catholic, Anglican, Methodist, Presbyterian, Pentecost, and other Christian, all these together, I can call them Christians. So from 1 up to 6, I recode that particular variable and I call 1 Christians. Then 7 is maintained as Muslim or Islam. And then 8, which is traditionalist or spiritualist, is also maintained. Then 95 and 96, I call that no religion or other. And then I generate a new variable called religion, as you can see here. So when I run these lines of command from this point to this point, and then I execute, I'm going to get a new variable called religion. I want to check whether the religion variable that I have created has the categories that I want. So I run this command, free religion, and then as you can see, very nicely done. 1 is Christians, 2 is Muslim, traditionalist, and then no religion or other. So I am done with religion. The next variable of interest is working status, whether the person is working or not working. And that one, to the variable name in the DHS is 3V714. So I just highlight this particular one, and then I execute. When I execute, I can see responder currently working. We have no and yes. So this particular one, I can decide not to recode it, but I don't like the no and the yes as the categories of the variable. I want to see not working and working. So I have decided to recode the original variable into a new variable with the new categories. So I have recoded this variable and generated a new variable as working status. So when you run this line of command, as you can see here, and then you free it, you get a new variable called working status, and the categories are not working and working. So what you do is that you do that for all the other variables that you are going to use. The next variable is health insurance subscription. That one too, you follow the same steps. Visiting health facility in the last 12 months, the same steps. Mass media exposure. We have the variables as exposure to newspaper, radio, TV, and the internet. So you use the same steps to generate all these variables. So assuming we have done that up to the last variable, which is which one? Yes, place of residence. Assuming we have done that up to place of residence, and then region, which is our last variable, what we have to do is that we have to check whether all the variables that we have created are in our data set. So for region, you can decide to maintain the original variable, or you can decide also to group them into the middle, southern, and then the northern belt, depending on the kind of analysis that you are doing. So as you can see here, that is what we did into the northern, middle, and southern belt. So this is where all the recodings and then all that you have to do, that is where they end. So what we are going to do is that we are going to run again from the beginning up to this point, so that we will have all the variables that we have created in our data sets. So you can run these steps over and over again. So far as you have all the lines of commands in your do file, you don't have any problem. If there is any error, just start from the beginning up to where you had that error, and then you are good to go. So I'm going to start from the beginning up to this point, and then I'll run everything. When I run everything, I get all the variables in here. If I want to check whether I have all the variables in there, I just run another command in Stata using the free. So I am going to free all the variables that I have generated. So when I free, you will see that I have all the variables from the beginning up to the end. So the first one is the breast test, with its categories as no and yes. As you can see, the sample is 15,014. There are no missings. Maternal age, which is the new variable I've created for age, it has its categories, the number of observations, the same, no missing. Marry, which is marital status, the same thing with its categories. Religion, the same thing. Education, we have it here. Working status, insurance, facility visits, new TV, exposure to TV, exposure to radio, newspaper, frequency of using internet, wealth index, place of residence, and the region, which has been grouped into middle, southern, and northern. So now we are done with our codings, recodings, our whatever we want to do before we start the analysis. We are done with that. So once you are done with that, now you come to do your actual analysis, starting with the descriptives. So the descriptives are just about percentages and frequencies, and you start with the outcome variable. So as you can see, I want to tabulate the breast test, which is my outcome variable, but in this time round, I am going to add my weighting variable to take into consideration oversampling and undersampling that happened during the sampling of the respondents. So I just tab breast test, then I have a bracket here, AW analytical weight. So the AW here is analytical weight, which is equal to WT, which is the weight variable I created at the top there. So you can see that particular variable in your data set. So when I do this and then I run, I will have my outcome variable, but this time round, you can see that it has taken into consideration the weight. So the frequencies and the percentages, as you see here, are different from what I had without the weight. So let's check this very well. Just check the frequencies here. You have 12,252.933 for the no category and the 2,761 for the yes category. the percentage is 81.61, and then for yes, it's 18.39. Just keep this in mind. Let's go to the top and go and check our original variable. So you see the original variable for breast test without the weight. The no category is 12,537 with a percentage of 83.5. The yes category is 2,477 with a percentage of 16.50. But when you add the weight, you see the percentages have changed. So that is why it is important for you to take into consideration the weights so that you avoid oversampling and undersampling, which might have happened when sampling the respondents. So when you are done with that, for the independent variables, if you want to also check their descriptives, that is their frequencies and percentages, you have to do that for each of them at a time, as you can see here, using the same line of command. Tab maternal age, and then you add the weight. Tab marry, you add the weight up to the last one, which is region. So when I run everything up to the end here, I have all the variables again, as I have done before, but this time around, weighting has been taken into consideration. So the number of observations and the percentages will be different. One thing you can do, if you don't want to do this one by one, you can use a stator command for each, which is a loop. And that can be explained very well when you have the do file. For each is a loop, and then what the loop does is that it takes all the variables that you want, and then it does the same thing you have done repeatedly as you have done here. So if I do for each variable or variable list, maternal age, marital status up to region, and then I put a bracket here, and then I say tab var, which is all the variables, and then AW is equal to WT, which is the weight. It is going to run all of them one after the other. But this one, you save time because you are not going to do it one after the other as you have done here. So let me just run it for you to see how it works. So you can either do this or do that. But for me, I think this one saves time. But you have to know how to do it. So I just highlight it and then I execute it. And then it does everything for me again, just as I have done here from the beginning up to the end here. So when you are done with that, you are done with your descriptives. So the descriptives, you can present them in a table with the frequencies and the percentages nicely done, and then you are good to go. After you are finished with that, the next thing you have to do is to do a chi-square test. And we have decided to do a chi-square test. Somebody can decide not to do a chi-square test. It is up to you. So if you want to do a chi-square test, there are also lines of commands you are supposed to run. And as you can see, I mentioned earlier that when you are doing any inferential statistics, you have to take into consideration the complex nature of the DHS data set. So you have to start the command with an SVY, and then you follow it up with the line of command. So as you can see, the original command is tab the variable, explanatory variable with the outcome, chi-square, confidence interval, and all that, and then you run. But because we want to take into consideration the survey set, we have to start with an SVY. So you start SVY colon tab maternal age, which is your explanatory variable, breast test, which is your outcome variable, confidence intervals with the percentages, we have the row, and then we have the format. The format is just telling you how to format the results. And then this one is telling you that you are supposed to have it in one decimal place. And then this is the 7 here represent the width that you want. And then the format of the data set, whether it is float or not, you have to indicate it here. You can decide to avoid the format from here up to this point. You can decide to forget about this. When you forget about this and you run up to this point only, it will give you still the chi-square with its percentages, but here the percentages will be in 2 decimal places. But when you add a format, it converts the percentages into 1 decimal place, and it makes the table very nice for you. So here, when you are doing any chi-square test, and this is not a time to probably explain into detail what a chi-square test is. But before you do a chi-square test, you know that you have to have an explanatory variable, an outcome variable, and then you have to have a row total, a cross tabulation with rows, and then the percentages, and then you have to have their confidence intervals and all that. All of them have to be done. But here, this is the command that you are supposed to use when you are running a chi-square test. So I'm going to run only the first one. So when I highlight this particular one, and then I click on execute, it gives me a chi-square test for age against breast cancer screening. So we have 15 to 19, the no category with its percentage and confidence interval, the yes category with its percentage and confidence interval. And here we are using row totals. So as you can see, for 15 to 19, the percentage total is 100. 20 to 24, the same thing, 100, with its percentages and frequencies. Percentages and then the confidence intervals, as you can see nicely down here. Beneath the table here, you will see the uncorrected chi-square, and then we have the design-based chi-square with these p-values. So as you can see, these are the p-values here, and then these are the chi-square tests. So you can use the design-based, which has the chi-square value here, or you can use the uncorrected version. All of them, you have to indicate in your methodology that this is what I am doing. Those ones have to be done here. On top of the table, you will see the number of strata. This is permanent, or this is by default in the DHS data set. The number of primary sampling units, or the cluster number, is here. The number of observations are here, and the design degree of freedom is also here. For each of them, when you finish, this is how the table will look like. And it is up to you to just copy them into Word in your manuscripts. So when we run for all the other ones, we are going to get the chi-square test with its result for all the other variables. As you can see, all of them have been generated using the same line of command that we used before. If you don't want to go through the stress of doing this one after the other for each explanatory variable and outcome, you can also use the for each, which is the loop. And it is the same thing, but in a loop form. So I am going to do that. And the line of command is for each var, that is for each variable or variable list. And you bring all your explanatory variables as I've nicely listed them here. You bring your bracket, and then the command that you run here, this particular command, you repeat it here. So SVY tab. So instead of having the variables, the explanatory variables one after the other, because you have used the for each, you just bring this particular var here, which is representing all the variables here. So SVY tab var, then you have your outcome variable, and then all the rest of the commands will be here. Nothing changes. You can run this from here up to this point, and then it gives you the same results as you have here. You see, it has run everything again, all of them. Instead of going through the stress of doing this one after the other, just use the for each, and then you are done. The next thing that we want to do is that after we have done our chi-square test, so what is the purpose of the chi-square test? We want to check the independent associations between each of the explanatory variables and the outcome without controlling for any other variable. So how is, for instance, maternal age associated with breast cancer screening? How is marital status independently associated with breast cancer screening? So what is important is that you want to check their independent associations using a chi-square test. So if we check the results, So let's go back again to the results and I will show you something. So if we check the results that you have from the chi-square test, how do you identify whether it is significant or it is not significant? You can only identify whether the associations are significant or not significant using the p-values. So the p-values are often found here beneath the table. So here for maternal age and then breast cancer screening, you can see that the p-value is 0.00. So it means that it is less than 0.01, even if we are using 99% confidence interval. So here, if it is less than 0.05, which we often use, that is our level of significance, it means that it is statistically significant. So any p-value that is less than 0.05, if we're using 95% confidence interval, it is statistically significant. So if we check, age is significant. Marital status is significant. Religion, the p-value is also p is equal to 0.000, which is significant. We have education, significant. We have working status, significant. This one too is significant. This variable is significant. This one the same. 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 Up to region, which is also significant. Why am I spending time explaining this? The purpose of doing the chi-square test is for you to select variables which are significant for the next step of the analysis that we are going to do. We have decided to do a regression analysis. Before we do the regression analysis, we have to check to see whether the variables that we have selected are independently associated with the outcome before we include them in the regression analysis. And this one has been debated by statisticians over and over again. Some of them are of the view that because you have selected your variables based on literature, and the literature told you that these variables are already associated with the outcome, it means that there's no need for you to do any analysis to check to see whether they are significant or not significant. So some statisticians are saying that chi-square test or any other bivariate analysis that you do before you do another analysis is not important. Others are arguing that even though literature will tell you that this particular variable is significant, you have to check to see whether in your study they are significant or not. That is why we decide to do a chi-square test to check the independent associations between the explanatory variables and outcome. So when you do the chi-square test and you identify a particular variable which is not significant, what we are trying to say is that if it is not significant, we can't include it in the regression model. We only include the ones which are significant in the regression model. This has also been debated by scholars and statisticians. Some of them are saying that you can have a variable which is not significant at a chi-square test level, that is, which is not independently associated with an outcome. But then it can be associated with the outcome when it is added to other variables or when other variables are controlled for. So there's no need for you to eliminate any variable which is not significant. But others are saying that if it is not significant at the independent level, it cannot be significant when other variables are added. So you don't need to include that. So this has been ongoing. So it is up to you to decide what you want to do, whether to include those which are significant in the regression analysis or not. It is up to you. And you have to state that clearly in your methodology. So for us, we are fortunate. All the variables are significant. So we have to include them in the regression analysis. And for the purpose of this workshop and what we are doing, because our outcome variable is binary, we are going to use the binary logistic regression. And binary logistic regression can be done in two ways. We can have the bivariate, and then we can have multivariate. Bivariate means that you are doing it one after the other, just as we did for the chi-square test. One explanatory variable, one outcome variable. Multivariate, or what others call multivariable regression analysis, means that you are going to put all the variables in one model so that if another variable is in there that has an issue, it can be controlled for. So for the purpose of this workshop, we are doing a multivariable logistic regression. And this is the line of command you use. Here too, you have to take into consideration the SVY sets, followed by the logit. So logit is binary logistic regression. Your outcome variable will come, then your independent variables will follow. As you can see, each independent variable is, or each explanatory variable is preceded by an I dot. The I dot is only telling you that this is a categorical variable. If it is a continuous variable, you don't need an I dot. And I am presuming that each one of us knows what a categorical variable and what a continuous variable is. So I don't need to explain it. So anything that you see here, I dot, means that this is a categorical variable. And when you start or you begin with an I dot, automatically you need to have a reference category. Because this is a categorical variable, it has categories. And you have to choose a reference category when you are doing a logistic regression. So when you precede it with an I dot, automatically the first category of each of the variable becomes the reference category. So here, because I've preceded it with an I dot without specifying anything, for maternal age, those who are in the no education, those who are age 15 to 19 are going to be the reference category for my regression model. I can change it and decide to choose which one I want. But that one, I don't want to talk about it now. But if you want to change it, it's just a matter of looking at which of the categories you are going to use or you want to use as a reference category and changing it. So I can change maternal age if I want to use the last category. Before I do that, I need to free maternal age and look at the categories and then the numbers attached to them. So the first category is having 1 as a label, 2 for the second, up to the last one. So assuming that I want to use 45 to 49 as my reference category for maternal age, what I need to do is to change the base reference category. So I will just clean this I start with a B, and then I bring a bracket, 7, and then I close it, dot. So the B here means that this is going to be the base, the reference category. And the 7 means that the 7 is for 45 to 49. So that is what I want to use as my reference category. So assuming you want to use 30 to 34, automatically you know that 30 to 34 is 4. So you just change this particular one, instead of 7 up to 4. You can do that for any of the variables, but you have to know the numbers that are attached to the labels. So let's keep the original one, which is the I dots. So we have SVY logit, our outcome variable, each of the explanatory variable preceded by I dots. And then at the end, we have a comma and then OR. OR is odds ratio. So you have to add that when you are doing a logistic regression. So it means that we want the results in odds. If you don't have or you don't add the OR at the end, so when I take this particular out, the comma OR, if I take it out, I am going to get the results in coefficients instead of odds ratios. And the coefficients, you can also explain that. It is up to you, but it is easier for you to explain that using odds. So I have my comma and then I have my OR for odds. So let me run this particular one and see what happens. So when I highlight it and then I run, I have my regression results here. I have the outcome variable here, each of the explanatory variables with these categories. I have the odds ratio, I have the standard errors, I have the confidence interval, I have my p-values. These are the p-values. So as you can see, from this result, maternal age with its categories, all of them are statistically significant with p-value 0.000.00 up to the end. But you can see that the odds ratios differ from 1.58 up to 3.54. But from here, as you can see, it increases as you age. So breast cancer screening, if you want to interpret this particular result using what we have here, it means that the likelihood of breast cancer screening increases with age, with the highest one being among those who are aged 45 to 49. And there are a lot of literature available to explain that, if you want to use that as the odds ratio. So if we check this particular result, 15 to 19 is not here because automatically that is the reference category. When you check for marital status, the same thing as we have here. Those who are never in union, missing from here because that is the reference category. And then it follows up to the rest of the variables with their odds ratios and their confidence intervals. Once you have the results in here, to make life easier for you, there is a way of generating the results and putting them in a table so that you don't have to now come and do copy and paste and come and type this one after the other. And let me tell you, when we started analysis and we didn't know anything, that is what we were doing. So you can spend sleepless nights typing them one after the other into your, into your table in Word. And that was time consuming. Now there's a way of doing that so that the tables will be generated for you. And that one using the stab command in Stata. So the stab command has to be followed by the sto. And these are commands that are not automatic in Stata. So if they are not there, you have to use sse install to install that in your Stata program. So you just highlight all these ones from here up to the end, and then you execute. When you execute, it will generate a table for you. And then the table can be found in this particular file. This file is in my folder. So when I go to my folder, which is this one, I can see it here. So it is here. When I double click on it, you see that the odds ratios with their confidence intervals, and then the stars are only telling us the p-values. All of them have been generated for me here. It's just a matter of me just giving the categories names as they are in what I am doing, and then you are done. You don't need to type them one after the other. Everything has been generated for you here, as you can see them nicely done. Okay, so this is where we can get to, and this is just an analysis using logistic regression, binary logistic regression. Sometimes you can do other kind of regressions, and there's one that is very, very important, which is the multi-level logistic regression. A lot of statisticians are using that for the DHS because the DHS data set is collected in levels. So we have the cluster level, household level, and then the individual level. So if you do a normal regression analysis like we have done, you have not taken into consideration the multi-leveling nature of the DHS data set. And you have to do a multi-level modeling so that you have the fixed and the random effect results to show that you have taken into consideration the multi-leveling nature of the DHS data set. But for the sake of time, we are not going to go through that because that one also takes a lot of time. The do file that we prepared for that particular multi-level modeling, as you can see, is very long, as you can see here. So we are not going to do that. First, let's understand what we have done today. And if time allows, we can organize another workshop specifically for multi-level modeling.